Hi students, today we are going to discuss a very fundamental chapter for the organic chemistry, that is general organic chemistry, that we are going to discuss in this session. And this is part 1 and the part 2 and part 3, and that will be uploaded soon. And in this session we mostly focus on these topics, and these are the first fundamental topic is what is a bond and the bond formation, and the remaining things we will discuss. And the types of bonds we will discuss, and different types of bonds we will study, and the fission of covalent bond, and which is very important. Mainly we need to focus on covalent bond fission, and what are the, in a chemical reaction we need some kind of a reactive attacking reagent. So the types of attacking reagents we will see, and in the simultaneously we will get a small introduction regarding what is an intermediate and what are the different types, and we will see the some of the characteristic features and how they will form, and all the things we will see in the further sessions. See, from the very basic we will see the what is a bond. And bond means, uh, we can say, a strong attractive force between two atoms. For example, let's consider two atoms like this, and there is some kind of attractive force between these two, and that force will hold these two atoms stays together by electron electron bonding. That is a bond, and this force is due to the resulting of the transferring or the mutual sharing of electrons from each atom. Let's say consider this is an H atom and this is a H atom, and these two atoms will donate one atom to this, one electron to this, sorry, and one electron from this atom. So electron electron will get paired, and the bond will formation takes place, and this is how a bond will takes place. And by definition we can write a strong attractive force that holds atoms together and this is due to resulting of mutual sharing or transfer of electrons. Transfer of electrons. The definition we can say like this, and the notes also I will upload as soon as possible after completion of this video. And you may get some doubt like, actually the atom structure will be like this, and the centrally positive charge will be there, and the negative charge electrons will surrounded by it and revolves around the nucleus. And if two atoms comes closer, and this electron contains negative charge and this electron also contains a negative charge, so this negative charge, some repulsion would be there. But when you compare with the nucleus charge, which is a positive charge, and the nucleus of positive charge, actually how these electrons, actually what happens in the bond formation, in bond formation we will see these electrons will be attracted by the nucleus of the other atom like this. I will give you a color indication so that you can able to understand easily. So this is the how attractive forces will take place. These attractive forces are more than the repulsive forces. The attractive forces are greater than repulsive forces. So this is how a bond formation takes place, and we will next move on to the next concept is the types of bonds. Actually, the types of bonds were three types basically. The number one is ionic bond, and the second one is covalent bond, and the third one is coordinate covalent bond. Actually, when we study the ionic bond, these ionic bonds are generally formed by the transfer of electrons from one atom to another atom. These are actually formed due to transfer of electrons. These are due to transfer of electrons. This ionic bond. Transfer of electrons from one atom to another atom. When you see in the covalent bond, the covalent bonds are actually, this is as I can write here so that you can see clearly. So the covalent bond is basically formed due to the mutual sharing. That means, for example, one atom is consisting of some electrons. That electron will be donated to another atom, and another atom will come and that will donate another electron, and these two electrons will form bond. But this is what a covalent bond will takes place. When it's coordinate covalent bond can be defined, which is the two electrons are basically required for a formation of a bond, and that those two electrons will be donated by a single atom. For example, BH3 is a low electron deficient species, and NH3 is a electron rich species, and which is consisting of a lone pair on nitrogen atom. So when these are in comes to the reaction, these when vacant p orbital will be there in the boron atom. So the two electrons of the nitrogen will be donated to the boron, and these will be forms a bond, and there is no any contribution from boron, only contributed by nitrogen. So this is the coordinate covalent bond, and we will see the next, the fission of covalent bonds, and this is a very important thing that we need to understand very clearly. Basically there are two types of fissions. One is homolytic fission. homolytic fission and this homolytic fission may happen due to there are so many reasons this fission will takes place. Basically, for example, let's say consider a bond A and B were there, and A and B are having a same electronegativity. That means electronegativity is a term very important in the organic chemistry, and as well as many of the things, electronegativity is a term very important. Electronegativity, which means the tendency to attract electron pair towards itself is called electronegativity. And these two electrons, I mean A and B, have a same electronegativity. For example, if a sunlight was fallen on this bond, and these bonds, I mean the paired electrons, two paired electrons were there, so one these electrons will, how they will dissociates, I mean how the bond breaking will takes place. A radical will form and plus a B radical will form. These are radicals. We will represent A dot and B dot. We call them in chemistry as radicals. See how actually this bond breaking will takes place. A and this is B, and this in the middle of the bond, one half-headed arrow that we call fish hook arrow, and another electron like this. So this is represents one electron from will comes to the A, and another electron will comes to B, so that it will comes A dot plus B dot, I mean A radical and B radical. This is homolytic fission. And we can say the most of the things, example we can see, for example chlorine will becomes chlorine radical plus chlorine radical, because these two have a same this bond Cl and single bond Cl, both are having same electronegativity. So this will have homolytic fission will takes place when it the case of a same electronegativity. Let's see in the other case. For example, let's see in the other case, that is heterolytic fission. Heterolytic fission. Heterolytic fission will took place a bond between two different electronegative groups. That means A B bond is there, and A and B are two different electronegativities. So for example, let's say consider if case, in a case A greater than B, so that A can attract this paired electron towards itself more than B. So these two electrons will move partially towards A because of electronegativity of A is electronegativity of En of A is greater than En of B. So how these will takes place? A bonded B gives, these electrons are moving towards A, means some negative charge is going on to the A. So A minus plus B plus will takes place. These fission, I mean heterolytic fission, will gives the cations and anions. Anions and cations are that means this is an anion. Anion means a charged species having a negative charge, and this is a cation. A cation means a charged species that contains a positive charge. These things will form in the heterolytic fission. See, for example, in the case 2 also we can see, this is case 1 and this is case 2. For example, the electronegativity of B is greater than of electronegativity of A, then the A bond B will, the paired electrons will move towards B, and these B electrons will transfer to the this place like this way. Here also you can show a full headed arrow because both the electrons will moving towards A. Here it's moving on A, so A plus plus B minus. Based on the electronegativity, we can decide these things. And the next topic which we need to discuss is the attacking reagents. Okay, we will see those reagents in here. Actually, attacking reagent means in any chemical reaction. What is a chemical reaction? Basically, a chemical reaction will take place when two A plus B uh, and this is a reactant and this is product will form some product C, some product will form by this reagent. This is B and this is the reagent. This reagent will attack on B so that A will transfer to the C. So this is actually reactants. Reactants will form products with the help of a reagent or a catalyst. Also we will use the catalyst in another case we will study in the chemical kinetics, this catalytic reactions and all the things. And basically we will see what is in a attacking reagent. Attacking reagent. Attacking reagents are basically three types. Three types. One is electrophiles. Electrophiles. Second one, nucleophiles. And third one is ambiphiles. And we will study these things. What is an electrophile, what is a nucleophile, and what is an ambiphile. And let's see first one. Electrophile, we will represent E plus, which means it is an electron deficient. Electron deficient species. So it behaves like a Lewis acid. Lewis acid. Lewis acid means, as it is actually, it's ready to accept, ready to accept, ready to accept. Ready to accept the electron pair. And for example, we will see NO2 plus or CH3CO plus or Cl plus are all cations like K plus. These things also all non-metal. Sorry, potassium is a metal, so this is no. All non-metal cations and the metal cations which have a vacant d orbitals. As like many of the like you can commonly say all non-metal cations and metal cations. And here, sorry to say this, K plus will also can act as in the specific reactions. So metal cations also I mentioned, which have a vacant d orbital. Vacant d orbital. I mentioned d orbital, but K is a special case. We will study in the further classes. And the next thing that we will study is a nucleophile. Nu minus we will represent. Nu minus means electron rich species which means rich species. That means electron density is more. Electron density is more, and these attacks electron deficient areas. That means deficient areas means electrophiles. These will attack on these things. So we can say this. These are Lewis bases. Lewis bases. So that what we can see, examples we can see many of the Cl minus, NH2 minus, and OH minus. These are all comes under nucleophiles. And what about things ambiophiles, that we will there is no representation for ambiophiles, but by definition we can say the species behaves like a electrophile as well as nucleophile. uh, Ambiophiles, ambiphiles species behaves like both nucleophiles as well as electrophiles. These are ambiphiles. You may get you may get doubt like how a species can act as a nucleophile and electrophile, both the things. Let me give you an example. We can see CH3 single bond, C triple bond N, and this is electronegative and this is partially positive. And this portion, let me highlight this portion. This portion will show a negative charge. So this portion is a nucleophile, and this portion will show a positively charged. So this it can act as electrophile. So these both electrophile and nucleophile characteristics existed within a one species, so that this species is called as ambiophile. I will give you the clear note on this in my link description of the video. And the last topic, which we will discuss tomorrow, that is intermediates. Intermediates are while the chemical reaction is happening, some intermediates will form. Those intermediates may be cations. Sorry, very much sorry. Those are like carbanions, carbocations, free radicals, carbenes, carbenes, and nitrines and arines. And these 6 intermediates we will study in the upcoming video. Thank you very much. You can find the note of this lecture in the description. Thank you very much.